All right, today's lesson is on linear inequalities of two variables. A linear inequality of two variables is similar to a linear equation of two variables, except we replace the equal sign with one of the inequality signs. For example, we had x plus y equals 5 as a linear equation. But I can write that four ways when it comes to inequalities. I could have x plus y is less than 5, or I can have x plus y is greater than 5, or x plus y is less than or equal to 5, and x plus y is greater than or equal to 5. I consider x plus y is strictly less than 5. Is 3, 2 a solution? Alright, so what you're going to do is evaluate. Remember, your x coordinate is 3, your y coordinate is 2. So where I see x, I'm going to put 3. So put 3. Where I see y, I put 2. 3 plus 2 is 5, but 5 is not less than 5. 5 is equal to 5. So we know that this is not a solution. Or I consider x plus y is greater than or equal to 3, and we want to know if 3, 2 is a solution. So again, remember 3, 2 is an ordered pair. X is 3, y is 2. So I have 3 plus 2 is greater than or equal to 5. So you have 5 is greater than or equal to 5. So because of this or equal to, this makes it a true statement. We know 5 is not greater than 5, but 5 is equal to 5. So it's greater or equal to 5, so this is true. So we're going to say 3, 2 is a solution. Alright, you may be asked to graph x plus y is less than 5. Before you can do this, you must be able to graph the boundary line, which is x plus y equals 5. Alright, so you can quickly graph this line by plotting the x and y intercepts. So we know that the y-intercept is 0, 5. And the x-intercept is 5, 0. Alright. But now, be careful. This says all numbers that add up to 5 have to be less than 5. So we're not including points that add up to 5. So what you're going to do, you're going to make a dash line. That's similar to the open circle on the number line. You're not including points on this line. So you're going to make a dashed line. Solid line means you include the points, but you're not including points that add up to 5 because this is strictly less than. And the numbers that are the combinations of ordered pairs that add up less than 5 are below this boundary line. So what you're going to do is you're going to shade this color, this section of the graph, to represent all points that are less than 5. All combination of ordered pairs that have a sum that are less than 5 are below this line. But you don't include points on the line because they actually add up to 5. And of course, any points above here adds up to a sum greater than 5. All right, consider the inequality 2x plus y is greater than or equal to 4. Is the ordered pair 1, 2 a solution? Okay, so x is 1, y is 2. So you have 2 times 1 plus 2 is greater than or equal to 4. All right, we know 2 times 1 is 2. 2 plus 2 is 4. So we have 4 is greater than or equal to 4. Because it's or equal to, this makes it a true statement. So yes, this is a point that's on that line. That's a solution to this inequality, I mean. So it's a solution. All right, if you were asked to graph this, again, you can just plot the y and x intercepts. I have a y-intercept of 0, 4. And I have an x-intercept of 2, 0. Now this time you're going to use a solid line because you're including all the ordered pairs that satisfy this inequality. So let's do that. You're going to actually use a solid line. And sometimes it gets a little tricky. Which side of the line do you graph? Sometimes you might want to use a test point. Notice that the origin is down here. If the boundary line does not cross to the origin, that's a good test point. So I know that's going to be 0, 0 there at the origin. So I'm going to put 2 times 0 plus 0 is greater than or equal to 4. If it's a true statement, you're going to shade everything on the side of the origin. If it's a false statement, you're going to shade everything above. So we know that 2 times 0 is 0, 0 plus 0 is 0. So is 0 greater than or equal to 4? Where 0 is not greater than 4. So that's going to be false, and 0 is certainly not equal to 4. So you're going to shade everything above the line. So everything up here is a solution to this inequality. Our graph 2x minus 3y is less than 6. Using the graph, write 6 solutions to this inequality. Well, again, you can use the x and y intercepts. I have an x-intercept of 3, 0 here. And I have a y-intercept of negative 0, negative 2. This is strictly less than, so you're not including any ordered pairs that are on the line. So you're going to use a dashed line. So your boundary line is going to look like that. And do we shade above or below the origin? Here's the origin point. Do we shade above or below the line? Let's test out the origin. So I got 2 times 0 minus 3 times 0 is less than 6. So 0 is less than 6. That's true. 0 is less than 6. We're going to shade everything above this line here. So these are all these ordered pairs that are not on that line and above it are solutions. So if you're asked to write 6 solutions, we know that 0, 0 is one of them. I could say 1, 0. Just anything in the shaded region. I could say, let's say 1, 2. I could say 3, 4. I could say 2, 4. Or I could say as far as 7 and 1. Anything that's in the green region. But now anything below here or on this line is not a solution to this inequality. All right, this concludes our lesson for today.